of logarithms. And so since logarithms can be considered exponents, they follow the same properties of exponents. So I just want to review real quickly. If we had x to the a, if we had x to the a times x to the b, our final answer would be x to the a plus b. If we had x to the a over x to the b, we would have x to the a minus b. And if we had x to the a raised to the b, we could rewrite that as x to the a b. And so since a logarithm can be considered basically an exponent, right? Going back to the fact that y equals b to the x, we can rewrite this as x equals log base b of y. These rules apply, right? So let b, r, and s be positive real numbers with b not equaling 1 and c being any real number. Then the product rule for logarithms is if we have log base b and the argument is a product of two things or three things, it's equal to the sum of each individual logarithm. So log base b of r plus log base b of s. And we can go both ways. We can expand it. So this would be expanding. And if I went in this direction, it would be condensing. So we make it smaller. Condensing. I think that's how you spell it. I don't think, maybe it's not. Okay. If we have a quotient as our argument, so log base b of r over s is going to be equal to log base b of r minus log base b of s. That's this rule here, right? Our exponents, we subtract them. And finally, the power rule, log base b of r to the c is equal to c times log base b of r. And so that is this rule right here. All right, so again, log base b of r to the c is equal to c log base b of r. So another property, we already saw in the last video that if you had log base b of b to the a, you get a because they're inverses of each other. The same is true here. A to the log base a of x is just equal to x. Again, because it's an inverse of each other, and so we get the same result. Okay. So what I want you to do is pause the video and try this right here. Of the 8 relationships suggested here, 4 are true and 4 are false. Using values of x within the domains of both sides of the equation, thinking about the properties that we just reviewed, make predictions about the truth of each statement, then test each with some specific numerical value for x, and then finally compare the two sides. All right, so again, pause, see which ones are true, which ones are false. All right, so hopefully you give that a shot. And so if we look at the first one here, natural log of x plus 2, does that equal the natural log of x plus the natural log of 2? And the answer is no, this one's false. The rule that separates them is if it's a product of the two, right? This is a sum of two things in the argument. We cannot separate them. Number 2, log base 3 of 7x equals 7 log base 3x. This one is also false. This is a product, and our product rule tells us that we sum the two logarithms. So this would actually be equal to log base 3 of 7 plus log base 3 of x. Log base 2 of 5x is equal to log base 2 of 5 plus log base 2 of x. That is true. That is our product rule. Natural log of x minus 5 equals natural log of x minus the natural log of 5. That is true. That's the quotient rule. Log base x over 4 equals log of x over log of 4. That is not our quotient rule, right? Notice you have a quotient inside here. We would subtract the two logarithms, not divide the two logarithms. So this is false. Log base 4 of x cubed equals 3 log base 4x. That is true. That is the power rule. We can move exponents inside our argument in front. So this becomes 3 log base 4 of x. Log base 5 of x squared is equal to log base 5 of times log base 5 of x. This is false. Looking at 6, this is the same form. The 2 would move to the front. Okay? This is different, and this is why parentheses matter. This would equal log base 5 of x times log base 5 of x. All right? And then finally, log base absolute value of 4x is equal to log base 4 plus log base absolute value of x. That is the product rule. So this will be true as well. And so let's see, we have 4 trues and 4 falses. All right. And so using this, try these as well. Try to break them up. This is the level of difficulty that you'll see for our logarithmic properties. So assuming x and y are positive, use properties of logarithms to write log of 8xy to the 4th as the sum of logarithms or multiples of logarithms. So notice there are 3 pieces here. Let me get my highlighter. We have an 8. We have an x. Whoop, I wanted to change the color there. And we have a y to the 4th. This tells me I'm going to have 3 logs. Okay? So when we separate, I'm going to first separate using my addition rule. So this will become log 8 plus log x plus log y to the 4th. So my first step is I'm always going to look for a quotient or a product, okay, to separate. So I'm going to separate these all using my product rule from up here. Once you separate using the products or the quotients, you're going to look, are there any powers? There is a power right here, and so that's going to move to the front. And so my final answer is log of 8 plus log of x plus 4 log y. And so a couple things to notice. None of these have exponents, and there are no products inside. All right, so example 2 here. Assuming x is positive, use properties of logarithms to write the natural log of the square root of x squared plus 5 over x as the sum or difference of logarithms or multiples of logarithms. All right, so here we have, we're going to start with the quotient piece. So again, we always start with a product or a quotient to separate. And so I'm going to have natural log of the square root of x squared plus 5 minus the natural log of x. So that's my first step. And now you're going to look, can I do more? Well, I'm going to rewrite this square root as a fractional exponent. Minus the natural log of x. Don't forget that. That's from our first step. So now this allows us to move the 1/2 to the front, and I'm going to have 1/2 the natural log of x squared plus 5 minus the natural log of x. And so when I look inside here, I'm going to see, do I have any products, or do I have only a product or a quotient? And the answer is no, I have a sum. And so I cannot go any farther in this problem. The expansion of natural log of the square root of x squared plus 5 over x is 1/2 natural log of x squared plus 5 minus the natural log of x. Assuming x and y are positive, write natural log of x to the 5th minus 2 natural log of xy as a single logarithm. All right, so with this, we're going to work backwards. You work from outside you bring in exponents, and then you combine using your product or quotient rule. So if I start here, I have the natural log of x to the 5th. There's nothing I can do with that, so I'm just going to rewrite it. Minus the 2 can move to the xy. So now I have xy quantity squared. Now if I look, I have natural log of x to the 5th minus the natural log of xy squared. I removed all coefficients in the front, which means now I can combine using my product or quotient rule. One logarithm, whatever follows the minus sign goes into the denominator. Whatever came before the minus sign goes into the numerator. So I have natural log of x to the 5th over the quantity xy squared. This is an acceptable answer. You could also do some simplification. X to the 5th, x squared, y squared. And so this is natural log of x cubed, y squared. So this is the best answer. This is also acceptable in my opinion, because you wrote it as a single logarithm. All right. So with that, pause the video and try the next following questions. All right, so write as the sum or difference of logarithms. Each logarithm should contain only one argument and no exponents. And so in number 1, we have a product inside as our argument. So this will equal natural log of 8 plus the natural log of x. Number 2 is similar. This will equal the natural log of 9 plus the natural log of y. Number 3 and 4 are quotients. So this is equal to the log of 3 minus log of x. So again, notice that the denominator follows the minus. We have 2 logarithms because there's a numerator and denominator. Log 2 over y is log 2 minus log y. Log base 2 of y to the 5th. This means we're going to move to the front. This is 5 log base 2 of y. This will move to the front. Negative 2 log base 2 of x. So again, notice what's inside my logarithms as arguments. 8, x, 3, like it is one term. Okay, one term. Log x cubed y squared. So this will equal log x cubed plus log y squared. That's my first step. I'm going to break it apart using the product rule. And now I use my power rule. 3 log x plus 2 log y. Number 8, start with the product rule. Log x plus log y cubed. And now any power rules. Log x, 3 moves to the front. Okay. Natural log of x squared over y cubed. This becomes natural log of x squared minus, since it's a quotient, natural log of y cubed. Exponents move to the front. Minus 3 ln y. Finally, log of 1,000 x to the 4th. That's going to be log 1,000 plus log of x to the 4th. Now log 1,000 you can evaluate. Log 1,000 is 3 because 10 to the 3rd is 1,000 plus 4 log x. And there's my answers, 2, 1 through 10. To write as a single logarithm, you start with any exponents on the outside and bring them inside, and then combine using your product or quotient rule. So here we only have a sum, so this is going to turn to a product, log xy. We have a sum of 2 logarithms with the same base, turns into a product, 1 logarithm with the product of those 2. Here we have minus sign, so 2 logarithms with a minus sign between them. This becomes the quotient. y over 3. So notice there's one logarithm. Natural log x over y. 17 involves a coefficient. So coefficients move to exponents. So this is log x to the 1/3, which you could write as log cube root of x if you want. 18, log z to the 1/5, which is log 5th root of z. Again, you can choose to write it either of those two ways. Finally, 19, we have to start with exponents. So this is equal to ln x squared plus ln y cubed. Now we have the sum between two logarithms, so that becomes the product of the two arguments. And there we get natural log of x squared y cubed. For this last part, evaluate the following using a log a of x equals x. And so 7 log 7 of 3 is just 3. 5 log base 5 of 8 is just 8. 10 log of 0.5 is 0.5, because remember, a log without a base written there is just 10. 10 log 14 is 14. E ln of 6 is 6. And E ln of 1/5 is 1/5. And those are your answers to the U try.